All right, time to cook. Quality is bad. I couldn't get it fixed, but try to increase the quality of the video as you're watching. So try to increase the video. In this one, we're just doing questions, okay? In this one, we're just doing questions. Please, let's enjoy. And here we're doing questions, questions, questions. So I'll start with tutorial 4. I can start with tutorial 4 or tutorial 3, whatever tutorial I'll start with. It's the same concept. That table of hours, and we just have to apply it. So if you haven't watched the table, then go to the link where I sent part 1. Here we're starting. Let's see here. So I want to do, first of all, I want to answer these questions on implicit and parametric. I want to do these implicit. I'll choose the hard ones. Then I'll do tangent and normal. I'll explain that now. Okay. I want to start. This is going to be parametric. Okay. This is the parametric one, and here these two are implicit. So let's just go through this. You are not allowed in this place to tell me that you still can't answer a question which says find the derivative. What? Come on, let's do it. You have to be able to at least answer this one. Find the derivative. Because you know what to do. It's either the table, okay, or you're going to be using the table with product rule, or with quotient rule, or with chain rule, but still getting things from the table. Okay, come on, you can't fail that. I will only do this number 1a, then the others you do it on your own. Okay, look at number 1a. Find the derivative of following functions. I just want to do questions. Okay, let me just, for the next 3 hours, do questions. So I'm going to go through this tutorial, then go through the next, then go through the next, then go through the next. So I'm just going to be moving as fast as I can with those other questions you send me through that. So here's tutorial 4. Let's go through it. Find the derivatives of the following functions. We start x squared cos 3x plus e to the x. So I'm going to say number 1a. This is tutorial 4. We're going through that. Okay, so this is number 1a. They say that x squared cos 3x, is it x squared cos 3x? Yes, plus e to the x log 2x plus 1. Cos 3x plus e to the 2x log of 2x plus 1. Okay, I think so. E to the 2x log of 2x. Yeah, let's quickly differentiate this. So did they say that this is y, or they just gave it to us? Find the derivative. Okay, so if they say find the derivative, you may not say let y be. You can just say d dx, the derivative of this. This is going to be equal to, let's differentiate. In here, we have two things multiplying each other. We have this a polynomial, both x squared, whatever. It's multiplying cos 3x. This is a trig. You have two different things multiplying, so you say uv. This is a uv type question. So you're going to use the product rule here. When we use the product rule, what does the product rule say? Bring the second thing, bring v, which is cos 3x, multiplied by derivative of the first. Derivative of x squared is 2x, plus bring the first x squared multiplied by derivative of the second, derivative of cos 3x. When we are differentiating cos 3x, this is cos of something which is not an x. So we're going to start by the cos outside. We differentiate the cos using the table. Go to the table which I gave you. The derivative of cos is negative sign. Does the inside change? No, it's still 3x. Then you say times the derivative of the inside, which is 3x. The derivative of 3x is just 3. So this is what we end up having. Then we're going to come and do this again here. So we'll now say plus. We now do for here. Okay, all this is for the first part. Now we are saying plus. This plus. We are now differentiating these two. And these two, this is another product rule, because they are multiplying each other again. This is a u, this is a v. So how do I do product? It says bring the second one, which is v. So you're going to say log of 2x plus 1 multiplied by derivative of the first, derivative of e to the 2x, so it's going to be times derivative of e to the 2x. It comes back. Okay, you first differentiate the outside. We know that it's e to the something which is not an x, so it's going to be chain rule. But for chain rule, you first differentiate the outside, which is e, without changing the inside. You don't change the 2x, you leave it like that. So when you differentiate e, the table tells you that the derivative of e to the x is e to the x. So when you differentiate, you don't change anything. So here it is e to the 2x, the derivative is e to the 2x, but then you then multiply by the derivative of the inside, the derivative of 2x, which is 2. Okay, So here you're going to have it being equal to, here it is going to be 2x cos 3x, then minus, going to be minus 3x squared sine 3x. Then it's going to be plus, okay, no, for here I didn't actually finish. What did I do? I didn't actually finish. Let me concentrate. Make sure you're concentrating. In here it's going to be plus. You now say the second thing. You now say the first thing, e to the 2x times derivative of the first. Derivative of log of this. It's when you're doing log x. Remember, it's 1 over x ln a. Okay, so it is 1 over, this is going to be times 1 over, the x is this inside. So it's 1 over 2x plus 1, ln of this base. What's the base? It's 10. So it'll be ln 10. Okay, times the derivative of the inside. Because you first differentiate this log, then you multiply by the derivative of the inside, which is by 2. So what you end up having is what, ladies and gentlemen? You're going to end up having, now for here you would have 2e to the 2x log of 2x plus 1. Plus, here it will be 2e to the 2x all over 2x plus 1 multiplying ln 10. Can you see this? Because this was log base 10. They just write log, it's base 10. So you should know that. So this is log base 10. So that's what you do. You see that? That's going to be the derivative you're done. Let's, man. You can do this one. You can do this one. You can do your own derivatives. Let's do part C because it is now two things dividing. Okay. We can do part C or we can do part E. Which one is whatever you want to start with. We can see sine 3x over x squared. So for us to do this sine 3x over x squared, this is going to be, we want the derivative of this. We want the derivative of this. You use the quotient rule, which we said is low d high. So what is low? X squared times d high, the derivative of the top. If you want to find the derivative of sine 3x, it's not sine x. If you want to find the derivative of sine 3x, you first differentiate the sine. When you differentiate sine, you get cos of what? Of 3x. The inside doesn't change. Then you multiply by the derivative of the inside. You multiply then by 3. Then it's all over. Then you say minus high, which is now sine 3x. D low, which is times. The derivative of x squared is 2x. All over now, yeah. So here it is all over the denominator x squared all squared. So what then happens is it becomes this 3 to be 3x squared cos 3x minus 2x sine 3x, which is over 6. Okay, it is over, sorry. We can say it is over x to the power 4. Okay. Now here you can have it like this. This is going to be the end and you can leave it like this. Okay. So what you can actually do is this is going to be, you can bring out an x. This is going to be 3x cos 3x minus 2 sine 3x. So here this becomes, it cancels with the 1 in the denominator, the x to the 4. X into x1, x into x to the 4 is going to be x to the 3. X minus 2 sine squared x. This is going to be over x to the power of 3. Can you see this? Guys, can you see this? My guy, do optimization and mean value theorem first. What about slope of a tangent and normal? I mean, equation of normal. The people who want to see that. I'm just finishing this tutorial 4, then 5, then 6. Let me do it in a sequence, okay? I know you really want to see it, but patience won't kill you, man. I'm still doing it, okay? I promise you. Now. Okay? I hear that. Now let's do implicit. So I'm sure you guys saw what happened. When we're just differentiating these, we did that low di, whatever, all squared denominator, and then, yep, you're going to find your thing and you're done. Now let's go ahead and let's do some questions that are harder for the next part. We're just going to be doing questions, okay? All the time. So whatever question you want, hold up, I'm going to do it. Put it in the chat. Put it in the chat like Tumo. Put it in the chat if you have a specific thing that needs to be done. So here, what am I going to do? I'm now looking at the next one, which is saying find the differentiation of implicit functions. Now, when you're differentiating implicit functions, ladies and gentlemen, boys and girls, this is a walk in the park. Anything which is called implicit is a function where you can't make x the subject. You can't make y the subject either. You can't make y the subject. So we call it implicit. If you can make y the subject to say y is equal to something, something, x, blah, 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 then we are going to say, wow, you've done good. So that's an explicit equation. But in an implicit equation, you can't make that. Okay? So how do we then do it? We can't separate y and x, which means we then can't get dy dx. We can't differentiate it like that. So how do we differentiate? We'll differentiate it like this. But what you must know is that you are going to be differentiating x and you're going to be differentiating y. You're going to be differentiating these things. And you're going to treat them as functions. You're going to treat x as a function. You're going to treat y as a function. When you differentiate x times y, those are two different functions. You're going to use the product rule. So first of all, you treat each of them as functions. And what you must know is that when you're a y, you differentiate it just like you do x, but you must put dy dx afterwards. So for implicit, let's go to number 2. Let's do real quick. X squared y cos y plus xy. So this is going to be differentiate this nice easy implicit equation. This is an implicit equation. So we say, sometimes you see books calling it implicit differentiation. It's differentiation of implicit equations. You must know it. You are just going to say the derivative d dx of this whole thing is going to be equal to, we differentiate x squared, we get 2x, plus we differentiate y cos y. Now this is going to be product rule, okay? Product rule. So what does it say? Bring the second one, cos y, times derivative of the first. Derivative of y is 1. Okay, you differentiate it like you differentiate x. But then after you should put dy dx. Okay? Plus here, what do? You now bring the first one, y, times derivative of the second one. Derivative of cos is negative sign. Then you are now going to say plus here xy. Okay? What do? uv. Product rule says bring the second one, y, multiply by the first one, plus bring the first, which is now going to be x, multiply by derivative of the second. Because it's a 1, you must put dy dx after. So in here, yes, there is again a dy dx, by the way. There is a dy dx here. Because anytime you differentiate something which is in terms of y, afterwards, you must put dy dx. That's implicit. It's simple. Remember the product rule. And remember, when you differentiate anything to do with y, put dy dx after. And then simply, this is going to be equal to, this is going to be plus or minus y sine y, then plus y times 1, which is y, plus x times 1, which is x, but this is dy dx. So this is going to be it. So this is what you'd end up having. X times 1 is x, then you should put dy dx. So what will actually then happen is you make this is going to be equal to 0. Okay, you should know that it was equal to 0 because you are going to also differentiate the 0. Derivative of 0 is 0. Now you're just going to make dy dx the subject and stuff like that. So first you take everything which doesn't have dy dx to the other side. You remain with cos y dy dx minus, here you say minus y sine y. Why is this one not having dy dx? Why sine y? It has. This is dy dx. Okay? Here, you don't forget your dy dx. Plus x dy dx. When it's going to say is equal to 2x plus x, that's 3x, goes to the other side, it will be negative 3x. No, but this x actually has, so it's just going to be negative 2x. Then what we're going to do is bring out the dy dx. So dy dx comes out. Okay, you're going to have minus y sine y. What would you say here? Plus x again. This is equal to negative 2x. So here, what would you get? You'd get it as put this. My network is glitching, guys. Anyway, you get your dy dx, and it's going to be negative 2x all over cos y minus y sine y plus x. Okay, you put this, and that's what you get. Now, anyway, let's go to the next type of question, which is the one which asks for equation of tangent of the slope of the tangent. Now, the moment they ask you for slope of the tangent, hey, you're going to differentiate and put the point where you are. You would have the slope. Okay, so slope of the tangent is just the derivative. Okay, so here you want to find the slope. You have to find m, and it's by differentiation. It'll be like this. Look at what it looks like. You'll be having it like this. Y is equal to x to the power 4. It's actually 3 minus 4x. Oh, something so simple. And equation or slope. Equation of tangent. Tangent is a line. Its equation is y is equal to mx plus c. So it needs to know gradient, then it needs to know c, which is the y-intercept. Look at this, what happens. What is going to happen is this. The gradient, you can only find it by differentiation. You need the gradient and you need the y-intercept. Y-intercept, you find it using the point. So it's easy to make equation of tangent. You only need m. And m, you find it by differentiating and putting the point. So let's differentiate. Here we have y is 3x to the 4 minus 4x. They want tangent. You say, Mr. Tangent, I don't fear you. I'm going to differentiate and put the point, and that gradient is m. Okay, even if they say find the equation of the tangent, you got to find m by differentiating and putting the point at x equal to 4 or whatever. You put the point where you are into the derivative. The answer you get is the gradient. And when you get the gradient, you have the gradient of the tangent line. And you can find the equation of the tangent line. So you're going to say, okay, this is my y. What I'm going to find is dy dx. So I'm going to say dy dx. This is not, remember, this is application. You're now applying your knowledge of differentiation to find these things. You know how to differentiate, don't you? You know how to use the table. So whatever they give me from this whole tutorial, I should differentiate using what I already know. Then I should apply adequately, appropriately, maybe, let me say. I should for tangent, for the gradient of the tangent. Gradient, you get it when you differentiate and you put the points. So differentiate, you differentiate. Drop the power. 4 times 3, 12. X to the power of 3 minus 4. Now let's put the point. You're going to say or you can say let x be equal to wherever they say. They said where is it now? It is equal to 4. So you're going to go and say let x be equal to 4. Where we were, let x be equal to 4. Now you have your dy dx, which is equal to your mem, and this is going to be equal to 15x squared minus 4. Look at this. You're going to put it, let me say, you say 12, then you say by 4 cubed minus 4. You just punch in the calculator and see what answer you get. What answer do you get there? Your m, that's the gradient. So you have it there. You're done. Finding of the tangent, you're like, really? So it's all about finding m. And m is for a line, but you don't have the line. So you're going to use the curve. You differentiate. I don't know. This is a fight. Anyway, find your m. It's unacceptable for you to tell me you can't find the slope of the tangent. Slope to differentiate and put this point. Here they want equation. Same thing. Equation of a tangent. Tangent is a line. So the equation is going to be equal to, you say y is equal to mx plus c. This is for tangent, okay? For tangent. To say m is equal to the, first you should put the one. What did you have? You skip 2 lines, then you put your curve. Your curve in number 5 is y is 4x cubed, then plus 3x squared, then plus 4x, then equal to 5. So what are you going to do here? You are going to differentiate. This is your y. You are going to find dy dx. Drop the power. 4 times 3, 12, x to the power of 2. Plus 2 times 3, 6, x to the power of 1. Plus the derivative of 4x. Okay, first take this 5 to the other side in the next step, which I skipped by mistake. So you'd say minus 5 is equal to the 5 will come to the other side. So this will be now plus derivative of 4x is 4 minus the derivative of negative 5 is nothing. So this will be just equal to 0. You could have kept it that other side, is still fine. Okay, you differentiate both sides, but anyway, you can say this is going to be equal to 0. So 4x, this is going to be equal to 0. Now, when you get this, this is your dy dx. This is your dy dx. What do you need? You have dy dx equal to this. What do you need? you need equation of the tangent. And to find equation of the tangent, you need two things, M and C. How do you find M? Why are you learning about this now? Because you can find M using differentiation. You have your gradient. Now you're just going to say, let x be equal to something. Where is that something? Here, they said at the point 1, 4. So this is x and this is y. So you now say, let x equal to 1. You put in dy dx. So you're going to say, let x equal to 1. Put inside dy dx. So you now have your dy dx is now equal to, so you can say m, which is dy dx, will be equal to 12 by 1 squared plus 6 by 1 plus 4, which is going to be 12 plus 6 plus 4, 2. There we go. Can you see? We get gradient being 22. Now we can write to say y is equal to 22x plus c. And we can only find the slope of the tangent. M is the slope. We can only find the slope of the tangent in differentiation. You differentiate, then you put the point where they said at this point, equation of tangent. You say to them, you guys are a joke. Tangent is a line. So its equation is y is mx plus c. And m, you find it by differentiating, then you put the point where you are. So you're going to differentiate from your dy dx, put the point. You are at this point, look for the x value as 1. So you come and put x equal to 1, you get your dy dx. Now you go, okay? You to make equation of a tangent, which is mx plus c. Now you have the m, now you need the other things, the c. How do you get the c? You go back to this point, okay, and this point gives you x, gives you y. So it will tell you what to put for x. So here we'll say now it's going to be 4 is equal to 22 by 1. What are you going to get here? You say plus c. You find your c. 4 is equal to 22 plus c. 22 is equal to c. Negative 18 is equal to c. So now you can now say y is equal to 22x. Then plus c becomes negative 18. And you're done. Can you see this? Equation of tangent. Tangent is a line. And you need the m. And you find it using differentiation. So you're going to differentiate, put your value, you have the m. Now you just need the c. To get the c, you need to substitute m first. Remember, you want y is equal to mx plus c. So you're going to substitute m first, then you look for c. By putting the point where you are, then you look for c. Okay? Now, what about if I want equation of the normal? Ladies and gentlemen, boys and girls, normal is still a line. So it's still y is mx plus c, but the m is now y is equal to negative 1 over m x plus c. So what happens is we have found m already using differentiation, and then we let this whatever equal to. Anyway, you want it to be in this form. What are we going to do? We need to, here, if m is this 22, then you're going to have y. Here, what am I going to do to find this negative half m? You put the function, you differentiate it, you let m be equal to something. Then you get your m. Now you're going to put it in here to say y is equal to negative 1 over 22x plus c. Look, you just can find c. Put the point where you are. You'll find c. Put the point where you are. So you now have this version. Normal. Just remember, the only difference is that for normal, you're going to find m using what? Why did we do this topic? Because you're going to find m using differentiation. Now, after you find m using differentiation, then you are going to substitute it and find c. Then you have the equations you need. Remember, for normal, it's negative 1 over m. You find m using differentiation. Then say negative 1 over that thing. You'll be saying y is equal to negative. That's what happens. This is the equation of the normal line. Equation of the normal line? Yes. When in finding m, for tangent, you use this form. You need this form. M, you find it from differentiating. Okay? For normal, you find negative 1 over m. That's what they want. Okay? You change the sign and you flip it by any means. Let's go to the next question. Number 6, you can do it there. It's just you put a power outside there and you do your quotient rule. Now let's do number 7, which is parametric. Let's see how to do number 7. We've done all these other things, implicit, whatever. We are now at parametric. Number 7, yes. Let's quickly find it. Look at what we do now. Okay, parametric. I'll go to optimization and the mean value theorem. I'm going to it now. No. Look at what you do for parametric. What do I do for parametric? I have dy dx. Okay, here. They want dy dx. I have x, y. So I can read it to say x is equal to a, then theta plus sine theta. So what do I get? I can get dx d theta because it's in terms of theta. Here you are going to find x is in terms of theta. You find dx d theta. How do I do it? A is just a constant, so it will never go anywhere because it's multiplying any constant. So let's differentiate theta. You get 1 plus the derivative of sine is going to be cos. Let's finish it up. Sorry for that. Derivative of sine x is what? Is cos. The sine theta is cos theta. Anyway, you get your dx d theta. So dx d theta is equal to, if you want to expand, it's up to you. I don't even care. A plus a cos theta if you want. Doesn't matter. Now you have y be equal to a multiplying 1 minus sine theta. Huh? Can we differentiate this? Yes. To get what? dy d theta. Because y is in terms of theta. This is going to be equal to a is a constant, it won't go anywhere. 1 like you'd say a times the derivative of 1 is nothing, 0 minus derivative of sine is cos theta. You see, you can find your dy d theta. You can simplify it if you want to say a times 0 is 0. Look, I have my a times o, which is 0. My negative a sine 2 theta. Here it is. Look at what then happens. This is very, very tough for me. You have your dy d theta and you have your dx d theta. Now you just put in the calculator to say, I actually want dy dx. So it is going to be dy d theta times d theta dx. Here, you know what? You don't have this d theta dx. What you have is dx d theta. So you say it will be dy d theta times 1 over. Now just put it. So it'll be 1 over d theta d, which makes it equal to dy dx times dx d theta. Okay, that's 1 over this. Here you'd say, come on, I don't know these glitches. dy dx times 1 over this. Okay, let's just put, man, dy d theta is what? Where's my dy d theta? You differentiated, you got your dy d theta and your dx d theta. So this is negative a, wait, my phone's ringing. Negative a sine theta times, you're multiplying 1 over d theta dx, because you will have dx d theta, man, because you actually want it to be, it's supposed to be times, here it's supposed to be d theta dx, so that we have x in the denominator and we have y in the numerator, because it's almost like the thetas will cancel, but never cancel them. It's almost like they'll cancel. So what you do is your dy d theta, you have it because you were given, that's parametric, mate. You get two equations. Y is a function of theta. So you can find dy d theta. X is in terms of theta. So you can also find dx theta. Now you want dy dx. You have dy d theta. You have y d theta. You have dx d theta. So you now say dy dx is dy d theta times d theta dx. But you don't have d theta dx, but you know it is 1 over dx d theta, which is your dy d theta is actually negative a sine theta times your 1 over is going to be now 1 over your dx d theta is a plus a cos theta. So it's going to be a plus a cos theta, which is going to be negative of a sine theta over, negative is now outside, over a tan cos theta. So here we'll be having the a and the a will cancel and you remain with this. Okay, this is cos. What is this? A plus a cos theta. So it is a plus a cos theta. Is this what it is? Let me just confirm. Okay, but here it shouldn't be negative. Surely derivative of cos is negative sine times, so this is going to be, since it was already negative, it would be a outside the negative here of negative sine theta, which makes it positive. So this is a sine theta, and this, the other one is a plus a. So this is actually a sine theta. There is no negative sign, so you have a sine theta over a plus a cos theta. You factor out a, okay, in the denominator. You don't just cancel like that. So you actually have it equal to a sine theta. Then here you are going to say a, open brackets, 1 plus cos theta, because you factor out a. You factor out a, you get 1 plus the a is gone, whatever cos. So here you're going to cancel the a's and you're going to get sine theta over 1 plus cos theta. Here you have your things. Don't separate this, leave it like that. Anyway, this is whatever, finding the equation of this metric. We've seen the parametric. It's a formula that you're going to do. You're going to get d theta, you're going to get dy d theta, but you want dy dx. So you will use this formula to say dy dx is actually dy d theta times d theta dx. But you don't have d theta dx, you have dx d theta. But you want d theta dx. What do you know? D theta dx, which you want, is actually 1 over dx d theta. So you can then use it like that and then whatever. Anyway, okay, sorry for that. Oh, it took a long time to just do this. Let me go to the different questions now. Tutorial 5, which a lot of you have been waiting for. Are you still there for tutorial 5, 2 and the others? Tomo, are you still there? Tutorial 5 now. Let's do them. Here, show that this is a solution of the differential equation. Just you have this one, is it? you need the second derivative, you need divided. So in here, in this, you're going to remove and put what the second derivative actually is. To remove and put what the first derivative actually is. Then y, you already have y. So you're going to try and put and see if it's going to give you 0. So what are you going to do? Differentiate this y first time, then second time. Okay, and you know how to differentiate. We talked about it. So the questions for derivative and derivative, they say is not coming. Okay, I'm coming back to do the questions on derivative and Leibniz, they say is not coming. Here when they say show that it is a solution of the differential, but you can still differentiate it. Let's say you have this. Find the second derivative. For you, find the first derivative, you need it. Find the second derivative, which you're going to put here. And so you're going to say second derivative, then you're going to put first derivative here, then you're going to put original function here. You multiply x squared times the answer you get for first derivative minus x times, so no, the answer is for second, minus x times the answer for first, then plus y, you get 0, whatever. Okay, and remember that here you're just going to use product rule. This is u, this is v, okay? And it'll be easy. Use your table to find the derivatives. Anyway, here show that these are all boring questions. Let's see this number 7. Here's the number 7 for the mean value theorem. What does the mean value theorem say? Mean value theorem is just something like this. They all call it the MVT. It just says this, that if they just say what the mean value theorem says, and then we're going to try. We don't have time. Mean value theorem says that there is, if I have, this is my graph, if I ever have a line which cuts my function 2 times, so here is my function, it's a curve. If I ever have a line which cuts the curve on 2 positions, like this, it's called, this is a secant line, okay? It's cutting your curve. If you have a line which is cutting the curve, then what you must know is that somewhere along the curve, there is a point where its slope is going to be the same as that of the line. That's the only way the line would cut the curve 2 positions. The curve is going to curve somewhere. And at one of the values where it's curving, it will have a slope. The slope of the curve will be the same as the slope of the line. So in other words, we'll be saying that the first derivative, okay, we'll be saying that f prime of x, which is the first derivative of x, that is how you get the slope of the curve. There is a point where it is going to be equal to the slope of the line, which is change in y over change in x. So you're saying f prime of x, there is going to be a point where it is going to be change in y will be f of b, because this point here, this second point down here, we are going to call it b, then here we are going to call it f of b. That's the final position. Then here, since it's on the left, this is going to be a, then we call this f of a. So this is going to be f of b minus f of a, change in y, over change in x, b minus a. This is going to be the same. So there is a point. Now you are going to find that point. Find it. And when you find that point for your mean value theorem, when you find that point for the mean value theorem, find it. It's so easy. It's a proof theorem. Mean value theorem is a proof. So you are going to make the first derivative equal to this thing. How do you make? You should actually first find f of b, then find f of a. Then you are going to find the first derivative. Then please make up this equation, equate the thing so that you can see and know. Now, when you get a solution, you should find that you're going to get x equal to something, blah, 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 blah. That answer you get, it should be between a and b, if you're correct. The answer you get for x, it should be bigger than a, but less than b. Do you understand? Then you'd have proved it. Because the me, that's what it kind of says. Do you understand it? Let's go to the questions. Did you understand? Why are people quiet? Hello? Did you understand? Hello? Did you understand what mean value theorem is all about? Okay, understood. Good. All right, so now let's do the question. Let's start with the continue. All right, let's start with the question. The first question is number. Okay, the first question is number 7. Here, whatever. We have this. Okay, so let's just go and do it. Don't think. Then the second, we have this. Let's just go and do it. Don't think. We'll see what to do with number 9 and number 10 and 11. But look at the first one. What are you thinking about? So I'll start even solving here. You have f of x being equal to 2x plus the root of x minus 1. Find f of 1. This is going to be 2 by 1. Okay, let me just take this. F of x is 2x plus root of x minus 1. So we're going to say f of x is equal to 2x plus the root of x minus 1 from 1 to 5. That is where we are proving this small thing. Find f of 1. This is 2 by 1 plus the square root of 1 minus 1, which is 2 plus 0, okay, which is just 2. Find f of 5. This is 2 by 5 plus the square root of 5 minus 1, which is going to be equal to 10 plus. All right, now what do I now need to do? Differentiate. So you rewrite f of x is equal to 2x plus the root of x minus 1, which is going to be equal to 2x plus x minus 1 all to the power of half. Let's differentiate. We differentiate now. F prime x, okay, this is our f of x. F prime x will be equal to the derivative of 2x is 2 plus the derivative of this. You drop the, that's why I taught you how to differentiate first. Here you drop the half, then you have x minus 1 to the negative half. Okay, you start with the outside, you start with differentiating the outside. Then you multiply by derivative of the inside. Derivative of x is 1. So this is going to be 2 plus, there is going to be half. Then you have again x minus 1 to the power of negative half, which is like you're going to say this is equal to 2 plus 1 all over 2 multiplying x minus 1 to the power of positive half, which is going to be equal to 2 plus 1 all over 2 root x minus 1. Okay, so thank you for giving me this derivative. Now what am I going to say? For my mean value theorem, I should know that f prime of x is going to be equal to f of 5 all over 5 minus 1. Those are the 2 points I had. Remember, it was from 1 to 5. So what is my f prime of x? 2 plus 1 over the square root of 12 minus 2 all over 5 minus 1, which is going to be 2 plus 1 all over 2 root x minus 1. This is going to be equal to 10 over 4. I hope I don't make a mistake now. I don't want to make a mistake in solving such a fraction on the left and the fraction of the fraction on the left and the fraction of the on the right. You want to break the. Okay, so sorry for that glitch. You get 2 equal to x, and you, since 2 is between 1 and 5, you can now say since 2 is in interval 1 5, you can now say you have proved that you'd have proved that in the you can say MVT is proved. Okay, 2 is between 1 and 5, which is what you needed to do to find a value of x which is between 1 and 5. I should move back a little. I was just solving. Here's the stuff. Did you see? Did you see what you wanted to see? Did you understand? Can I continue to the next one? For number 8, okay? Find f of 8, okay? Find f of 0, find f of 8, 0, find f of 8. First find f of 0, find f of 8, find the first derivative, then make that formula. F of 8 minus f of 0, O over 8 minus 0 is equal to the first derivative. You find an answer. You should find an answer of x which is between 0 and 8. Okay? You should find something which is harder. What is it? Number 9. And we have number 10 and whatever. So here, what do we have in number 9? Number 9, we have an interval, okay? They're saying in number 9 that use the mean to show that the modulus, this is